All right, so welcome back. We are starting solving equations today, and so not that. Let's see here. Okay, cool. So these are the notes, okay? You don't have anything to write on, because I just want you to pay attention up here. So if you got a phone in your hand or headphones in your ears, so here we go. First question, what is the goal in solving an equation? Anyone know? Like any of these four at the bottom, like what would the goal be? What's your final result?
Solve it.
What does that mean? Perfect. Okay, so when x is by itself, you all heard that before? Now usually that means x by itself on the left side of the equation. Technically, if you have it on the right side, that's fine, and then you can flip it over. But there's a fancy way of saying that in math. It's called isolating the variable. Okay, so you know isolation is to be by yourself. So that makes sense, by itself. And the variable is x, at least in these equations. It could be another letter, but so isolating the variable, that's your goal. You are trying to get x by itself. Now, to do that, okay, you're messing with an equation. You're manipulating it. You're changing stuff, right? And we need to know the four operations. I know you know what they are, but what are the four operations things that you can do with numbers to change them? Subtraction, addition, multiplication, division. Okay, those are your four operations, right? Now, of those four operations, two pairs are opposites. Let's start with addition. What's the opposite of addition? Subtraction, right? Let's see if I can write on this. Okay, so addition. Here, hold on one second. This is a new program for me. Okay, there we go. Nope. Okay. Cool. So the opposite of addition is subtraction. And the opposite of subtraction is addition. Okay, so they go both ways. So if I wanted to get rid of plus 5, I would subtract 5. Well, if I want to get rid of a minus 2, I would add 2. Okay, you just do the opposite. And then the opposite of multiplying is dividing. Okay, so, and I use a dot for multiplication. If you ever wondered why a dot? When you grew up, it probably was like an X, right? Well, the problem is if you have an X in your equation, some people, it might get confusing. Is the X a variable or a multiplication sign? So that's why we use dots. Now, if you know which of these are opposites, adding and subtracting is opposite, multiplying and dividing are opposites. Opposites cancel out, okay? Now, there's a fancy word for opposites. Again, I try to give you the obvious, basic word, but the big math word is called inverse operations, okay? Inverse operations. So when you're solving an equation, you're just doing the opposite one of these four things, okay? So if you know which ones are opposite, and you can figure out what you need to get rid of, then you can solve an equation, right? And again, you should have already done this, but even if you haven't, today you'll learn, okay? Because that's what I like to do. If I teach it to you, then you can't say you never learned it. You got your back, okay? So start with that first equation over here on the left, x plus 4 equals 3. Now, if we're trying to get x by itself, isolate the variable, then what do I need to get rid of on the left side of that equation? The plus 4's got to go. Now, how many of y'all have done this before or been taught to kind of draw this line down the equal sign? You don't have to. In fact, eventually you want to get away from that. But even if you mentally think about it, that's the dividing line. Everything has to be equal. I know you know this is an equal sign, but when it comes to equations, it's all about equality, okay? So things must stay equal. The only way they'll stay equal is if you do one thing on one side, one thing on the other side, right? If I gave this half of the class pizza, this half of the class would say, that's not very equal, okay? Because I didn't do it on both sides. You get the idea? So that's how we keep it equal. We do it on both sides. Now, we said that the plus 4 got to go, and we need to do, yes, the opposite. The opposite of plus 4 is minus 4, okay? So now this is the important part, everybody, because I want you to show your work. Now, I know these might be super easy to you. You might be able to do them mentally. But starting tomorrow and the next day, when it starts getting multiple steps and all this stuff, I need you to show your work. So show me your work on the basic stuff, and then show me your work on the harder stuff, right? So the opposite of +4, I'm going to write right below it, -4, okay? And, well, we will. If I do it on the left side, do it on the right side, right? Pizza for both sides. All right, now, the reason why you did an opposite is to cancel something out. Okay? You're manipulating the equation, you want x by itself. So if you do some opposites, you got to show me that you know that they cancel out. So I like to just slash through them, okay? So opposites eliminated, okay? So I'm going to bring down x. So bring down x, bring down the equals. 3 minus 4, what is that? -1. X equals -1. Is x by itself? On the left side it is, so you're done. You solve for x. Okay. Next one. Very similar, but a little different. Okay. Quick. The opposite of, now, again, I'm trying to get x by itself. Does everyone see I got a -5? I need to get rid of a -5. What's the opposite of -5? Adding 5, so +5. And if I do it on the left, do it on the right. Okay. Getting the idea? So I crossed out the opposite stuff because it goes away. That's what I wanted, to do inverse operations and eliminate something. So the leftovers got to come down, you know? So x, and then the equal sign comes down. 9 plus 5. Okay, 14. Is x by itself? Yes, okay. So you get the idea. These one-steppers, it's just one step. It's not that bad, right? Again, I wish all year it could be that easy, but we got to have to just first week basic stuff. Okay, now the next one. This is where people goof up. Okay, now not y'all are going to goof up. Y'all are all smart. Okay, here's the deal. 3x. If they're just hanging out right next to each other, there is something implicit, which means something implied between here. So it's not there, but what is implied between 3 and x? Multiplication. So if you don't know that, you got to know that. That's never going away. If you have 3x, that means 3 times x. If it helps you, then you can draw the little dot. 3 times x. If you know it's multiplying, then you should know the opposite of multiplying. What's the opposite of multiplying? Dividing, okay? So if I have, by the way, let's see how smart y'all are. What's the name of that 3 in front of x? What do you call that number in front of a variable? There's a name for it. No, that is a product in the sense of they're multiplying, but there's a name for the 3. Starts with a C. Okay. So it's a coefficient, okay? Fancy word for the number in front of the letter, okay? So 3 is the coefficient. If you see a coefficient, you've got to divide, okay? So to get rid of that 3 times x, we're going to divide by 3, right? Do I just do it on one side? I do it on both sides, right? So when I divide, I'm going to get rid of that 3, cross it out. Life's good. Bring down x. What's 12 divided by 3? 4, okay? So we've seen 3 operations and their opposites. The last one is if x is being divided, x divided by 5, or if you see like a fraction, x over 5, that's dividing, right? So we want to think of the opposite. What's the opposite of dividing by 5? Multiplying, right? So again, you know that multiplying and dividing are opposite things. So if I'm thinking of the opposite of dividing by 5, I'm going to put what? Multiplying by 5, okay? So again, I use the dot just so I don't get confused with the x. Times 5 on the left, times 5 on the right. And the 5s cancel out because they're opposites. I'm left with x equals, what's 7 times 5? 35, very good. Okay. Now, I know you didn't have paper to write that on or whatever, but this is just showing you, okay, it's going to stay up here. If you have addition, you got to subtract. If you got subtraction, you got to add. If you have multiplication, you have to divide. If you have division, you got to multiply. Okay? So today's assignment, I'm going to give you a worksheet, like 20 of these, but it's just getting practice on the one step. Okay? Enjoy while you can. Tomorrow, the next days will be multi-step, okay, two-step, multi-step with distribution and multiple variables on both sides. It can get complicated real quick, but today, one step. Show me you can do that. Cool. So I'm going to pass that out right now. You want to finish it today in class, turn it in. If you don't finish it in class, you can finish it at home, bring it back tomorrow, okay? Here's the big problem, though. This is actually a pretty big problem that I did not calculate. I thought we'd have calculators by now. We don't, okay? Now, I don't mind you using calculators to compute. Like, if you were not 100% sure about 12 divided by 3, no judging, okay? And I understand little calculations. You still got to show your work, okay? So you can use your phone, but I know not everyone has one. So the only thing I have is a little calculator, okay? So if you don't have something you need a calculator, you can come use a little pink calculator, okay? Cool. So again, I'm going to pass this out, and we will get started. It's due tomorrow, but if you finish today, you just turn it in, okay?